Okay. For those joining us, we are talking about GPU support and how to show which functionality has default GPU support in Wolfram Language. So I guess NetTrain has a target device option. Is that correct?
That's correct.
Oh, look what just happened there. No, that was. Isn't this supposed to have separators? Sorry, this is a question for Sushma, I think, more than anybody else.
Yeah, it is supposed to have separators. I will report that.
And it's also, I think the line spacing is a little bit generous here. Maybe not. Maybe that isn't so bad. But anyway. Okay. Okay, so in NetTrain, we have a target device option. So now I supposedly have this machine that I'm connected to with a remote kernel, which actually has a GPU that works as opposed to my desktop Mac that doesn't. And so, boy, I see. So let's see. So if I say this, it'd be nice if this example didn't have a raw n equals, but anyway. Okay. So here we're going to build that. Okay, fine. Now, what are you doing here? So you're saying this is going to train the thing. Great. Lovely. What's that?
That's shouldn't happen. What's happening here? CUDA. I see. I wonder if this is the bug tally that. What GPU is this?
I don't know. You tell me how to find that out, because that's one of the questions here.
Yeah, it's. I mean, it's a NVIDIA 1080.
Okay, so let me just find out. Okay, so this is my challenge. How do I find that out? I've got my Linux machine. How do I ask it? What?
So you can. The easiest way is with CUDA link. So you can do CUDA link.
Okay, what is this, by the way? The child process reports MX get GPU count has failed, blah, blah, blah. Okay, so what should I do here? And did Fahim join us, by the way?
Yes.
Okay. Okay, so now what do? I have to load CUDA link, is that correct?
Yes.
I'm quite sure that it probably won't be. I'll be surprised if that works.
And then you do CUDA information.
Open, close?
Open, close. Now this might download something large.
What is it downloading?
It's downloading the whole NVIDIA CUDA toolkit.
Okay.
So something we haven't done yet, which we need to do post 12, is to basically share the CUDA toolkit between neural networks and CUDA link so that it's not replicated like this.
Okay.
The truth is that it's already shipped, so we already include this in the builds, and we could avoid this whole downloading process. But that requires some coordination that we haven't done yet.
Okay. Okay.
And I'm quite sure that this is not going to work because we haven't released the NVIDIA toolkit packlets for Linux in version 12.
Okay. Are they ready or are they far away?
For Windows, it is ready, and for Linux, I just have to test. But beyond that, yeah, I just haven't gotten to testing it.
Okay.
So in 11.3, everything should be okay, but all this new stuff might not work.
Okay, fair enough. But so in a first approximation, so first thing is that in system information, for example, we currently don't have anything about GPUs. Is that true?
I think that's not quite true.
Okay, well, we'll find out in a moment.
A front end has its own way of figuring that out, but maybe it depends on CUDA link also.
You could try start a second, yeah, exactly, second notebook with a different kernel and say something like system information.
Well, sure. I mean, if I just say that over here, this is just a kernel on my local machine. So if I say system information here, God, this is really slow. Okay. So machine here. Wow. Okay. System specific. I don't know what, I mean, other than that's lovely. I didn't even know we had that stuff, but
yeah, try devices, exactly.
And where would this normally be? Would it be under devices normally?
I actually don't know.
Okay. Okay. Well, okay, so that has to be looked at. All right. So then the next question is what are the things we wanted? So which functions, like things like speech recognize, somebody's commenting on the live stream. Well, let's try find out whether this particular, let's just see whether this code even works let's just see whether the code works. So let's just see what happens. So this is just running on my local machine where I don't believe I'm able to use the GPU. I don't even know if it has a GPU. Does a Mac Pro have a GPU?
It does, but I believe it's an AMD, so CUDA stuff is not going to work.
Yeah, you should get a nice error, and if you don't, it's a bug.
Yeah, minor thing for Sushma to report. I have no idea whether that's a dash greater than sign rather than a rule in that output.
Okay.
It'd be nice if this had a failure box rather than just a $fail. But anyway, okay, minor issue. Okay, so now if you're saying if I change the target device to CPU, then I should just get a happy training process going on, right? Albeit slower. Okay. So let me just understand what functions. So it's things like speech recognize that under the hood could use a GPU. Is that correct?
Yes,
anything
that was built with neural networks can use GPUs.
Okay. But the question is, we need to tell people, so it won't use GPUs by default because you don't know what else is going on the GPU on your machine. Is that the reason? In other words, you don't want to just preemptively say, sure, just go ahead and use the GPU.
Exactly. So it's dangerous for us to do that.
And there's no framework in the world where it's like, use a GPU if nothing else has grabbed the GPU. Or okay, let me ask a naive question. How does scheduling work for GPUs? Or doesn't it? It's just amazing in the computer industry. I mean, these things where, back in the day, there used to be this one sort of attached coprocessor that does this one special thing. And then, gradually it gets incorporated into the CPU and gets sort of scheduled by the operating system. I have to say, I thought GPUs would go that way and wouldn't survive as standalone objects, but I was wrong. But how do you schedule GPU operations? Guys?
By scheduling, you mean?
Well, I mean, you've got two processes that are both trying to use the GPU. What happens?
But I mean, so, what two processes are you referring to?
For example, let's say I had two Wolfram Language kernels, right? That were both doing this operation and both said, I want the GPU. What happens?
Oh, I mean, like the NVIDIA drivers will naturally take care of that. We don't need to worry about that.
What does it do? What does it do?
It just shares them.
Well, but how does it load memory? I mean, so it must have a scheduler. So it must know to load the thing, do its thing, unload it, do the next thing, and so on.
The loading is very manual. That's the job of the library. It's like MXNet.
Okay, but guys, if this thing's going to run for 5 minutes of GPU time, right? And you're trying to run another thing for 5 minutes of GPU time, when does it get interrupted?
I mean, that's not up to us. That's the operating system does that. So like if Firefox decides that it needs the GPU to, like render some video, that's not up to us to interrupt it. We can't control that. That is up to the operating system to adjudicate that.
Okay, but I mean, that's normally what a scheduler would do, right? But so, by the way, this seemed to do nothing.
Right, as I said, it won't work in 12. You'll probably have to fire up 11.3.
Okay, hey, Roger, then how do I get an 11.3 working on that remote machine?
I'll...
Or should I instead just go and SSH into that machine and just try a command line thing? I could probably see it in the command line, or will it do something fancy?
No, you should be able to do it on the command line.
Oh, great. I need a raw IP address, please.
Can you paste us that?
It's not in DNS. What's that?
Can you paste us that error message as well? That last internal failure. That's going to be very, very useful for us.
This thing here?
Yeah, that whole block.
Well, why don't I just give you, okay, fine. We could be modern and use the chat framework, and I could just send this to you like this. That's too modern for you guys? Here, I'll send you the box structure. Okay, let me ask another question. For QA, what is their situation with testing all this stuff? Because there are obviously many GPU configurations.
If I have any say in it, it's pretty bad currently. It's all. So the first problem is we don't have enough hardware to test it.
Okay. But there are many different configurations, so we'll never have all that hardware.
Right, and so what we do is one of the reasons why MXNet and CUDA link are so big is that we put in all the flags for different compute capabilities that are supported by the GPU, and therefore it is so big. So we just assume that we have done the right thing, and we send it out in the world, and then users tell us.
Okay. Hey, Roger, how do I get to 11.3?
You need to do needs.
Yeah, but how do I get to 11.3? Because this is the wrong thing anyway.
Awesome.
How do I get to 11.3?
Yeah, I'm sending that to you. It's in user local Wolfram.
Well, just send me the link, please. Send me the thing. Oh, can you just send me the path, please?
Yeah.
So I don't seem to be getting anything here. You send me the path, please.
Yeah. Hold on. It didn't like that.
Send it by email if you need to. Send it by any method you need.
Yeah, I just did. Okay. I need the quotes around that, but just remove the quotes.
Why is it in the Mathematica directory?
Well, there's a desktop directory too.
Okay, fine. What's the name of the executable? What's the name of the executable?
Wolfram.
Like that? Is that correct?
Hold on, I'm on different screens right now.
Okay.
It's lowercase w.
Okay, there's 11.3. Okay, so needs CUDA link. Okay. Oh, come on.
So we actually.
Okay, let me go.
So I figured out why this wasn't working in 12. So we're just not catching this error properly and it's reporting it properly. But basically the problem is that the driver version is too old. So this is
okay. My driver for CUDA is too old, or what?
Yeah, that's probably
exactly.
it.
Okay. So can we force an update? Okay. So let me just understand. This is in Linux, right? So I don't even remember how you get machine information in Linux. What's it called? The gosh, what is the Linux command to get machine information?
What kind of information do you want?
Yeah.
I mean, there's like LSPCI to list the.
This is NVIDIA SMI is the, if you want. Okay.
Okay. So magnificent. But so what is it? NVIDIA?
So it's NVIDIA and then dash SMI.
Space dash SMI?
No space.
Dash SMI.
Okay, so fine. It's not installed.
Well, so why don't I install it? I mean, is that the and how did it know? I don't understand how it knew to tell me that it could be installed when it wasn't installing it.
So, okay, there's a few things. Let's see. So this can be an involved process to install this. This is probably, and also there's a silly thing with Ubuntu, which is that it doesn't have the latest drivers. So there's a special way of getting them.
Okay, hold on. So this is saying, do you want to continue? What is all this horrific stuff that's happening? Okay. This seems so modern. Reminds me of a boot sequence from back in the early 80s. You don't usually see these boot sequences anymore. Don't install NVIDIA from APT. It will break everything, says Ethan on our live stream. Oh dear.
Yeah, this is, like I said, this is a dangerous, you're playing a dangerous game here.
Well, this is not my primary machine, so this is a secondary machine. In fact, it's my kind of play Linux machine. Okay, but in any case, so what I'm trying to do is I'm trying to get some indication of, what I would get. There's a way of finding out what the CPU version is in Linux and so on. That we use that for machine identification. I just don't remember what the name of the command is. Okay, so let's try the same thing. NVIDIA -SMI. Is that correct?
Yeah.
Oh, for goodness sake.
It's a nightmare getting.
I'm not impressed. This is,
It's notorious that it's notoriously hard to get it working on Linux.
Well, where is it not hard to get it working? You told me Mac doesn't work at all. So is this like a Windows only deal? So
Windows is the main gaming platform. So it is the easiest to install in Windows for sure.
Hey, Roger, can I get to my Windows machine from here easily?
Not, I mean, to like a remote kernel or something like that, or
yes.
No.
Is it configured to have remote kernels?
No.
So I have to go to the KVM switch and things, which is not going to be useful for everybody else.
Right.
I mean, I could run Zoom on the Windows side of the KVM. Yeah, that's too complicated. Okay, so we're doing really horribly here.
Yeah, and this is completely out of our control. Like the user really has to, get this working themselves.
And do we have any way of checking whether it's working before we start generating giant pink error messages?
Sure. So that's just a bug. Like we have a check that normally sees what the version or what the driver version is, and we give a report. We say we require driver version whatever, and we even give a link to a website where you can download the driver and all this sort of thing.
Yeah.
It just somehow wasn't caught in this error message, so I'm just not sure why.
Right.
Usually it should. Yeah.
So Ethan on the live stream is saying our own system information should do this. We absolutely agree, but we can't do it unless we can even get the data. I mean, in other words, so right now, where is, I mean, I'm, to ask a very basic question, is the GPU a /dev/something or other? What is the GPU in terms of the Linux operating system?
Fahim?
I have no idea. Sorry.
Do we have somebody around who would know? George on our live stream is saying that he had a lot of trouble getting this to work even when Apple had NVIDIA GPUs, and he was hoping that our company would do the heavy lifting to make all this stuff work. Great, thanks. Okay, but back to, so let's see. I wonder if there's anybody who we could pull into this meeting who would know this. Do we know anybody in the systems group who would know this? That's a deafening silence. Let's see if we can reach Warren.
Okay.
You can ask him if he knows anything about Okay, so we're doing absolutely horribly here. So let's try to understand. The original goal here was to figure out, okay, so for example, Sebastian, if I look at your machine, will it run with target device arrow GPU?
Yeah, sure.
Okay, so these commands will run on your machine. So why don't you go ahead and share your screen and just show us the results of these things? Does that make sense?
That makes sense.
Okay, so I'm going to unshare. Can you share?
Yes.
Okay.
1 second. So I'm plugging my massive monitor, which causes issues. Okay, there we go. Okay, do you see my screen?
I do. We see a bunch of Stack Overflow stuff.
Yes, looking at for installing the CUDA stuff. Okay, so we can maybe just have a quick look at the target device.
No, I want to see your CUDA. I want to see you load. Okay, this is gonna. Okay, let's try it. Try it. Okay. Am I going to see anything different in the display here that says it's GPUing?
You will not.
Well, it says comma GPU there.
Sorry, except for that. Yes. Okay, so this works.
Okay.
So
by the way, we've got lots of heavy breathing here. So, CUDA link. Okay. Now let's see CUDA information.
Oh no.
Oh, for goodness sake! No. And you may not have as fast an internet connection as I do. Why is that having to load something? Okay, Fahim, do you have a version of this that's running?
So we have other options if you really want.
No, but Fahim, do you have a version that's running?
I haven't even. I don't know, but I can try. But I'll let you know if it works. Okay.
Okay. Okay. Let's go back. So someone here. I don't know how to refer to people on a live stream when they don't have plausible first names. Designed by the suggests a command. Let me see what this does. Who knows what this command does? Sudo lshw. What is lshw? Oh, list hardware. That's interesting. Wow, that's more modern than I've ever seen. Fascinating. I don't remember that. That wasn't there back when I.
Stephen.
Yeah.
It's working on mine. At least CUDA Q gives true, so I'm hopeful that it will work. So what do you want me to do?
Okay, hold on. I want you to run CUDA information, but first of all, I'm looking at this. Okay, so what does this mean? No, that's a display. What is this? That doesn't seem to be anything to do with. What is this? I'm so confused. This thing is behaving like a VGA. Oh my gosh. And how can the clock be 33 megahertz? I thought these things were blindingly fast. Okay, who understands what this is talking about here?
I mean, the clock speed is always going to be a lot slower than CPUs. There's just a lot of them.
But 64-bit width, it says, which is not that much. Oh my gosh.
This is Warren.
Hi. Okay, we are trying to figure out about machine configurations with GPUs. Maybe you know about this, maybe you don't. How do you find out? You're sitting looking at a Linux machine. You want to know how is its GPU configured, or even if it has one.
I mean, you're probably going to do LSPCI would give you things connected to the PCI bus, which would give you very basic information. Probably.
Okay, well, I just did that on my machine, so I don't even see anything here that is. Oh, I see. Audio device, NVIDIA, blah blah blah. But I only see one NVIDIA
compatible. It's just like fifth from the bottom.
Oh yeah, there we go.
Yeah.
What does that mean? Why does it say VGA compatible controller? That means VGA like the display standard?
Yeah, I think this is just Linux or whoever wrote LSPCI just being a little bit conservative in how they're displaying names there to say that, oh, hey, this is just a video controller or a video display device, not the fact that it's this is some
yeah, I understand.
Either so HDMI device or display link or whatever.
Does this thing show up in /dev or is it not of that type?
I don't actually think that shows up. Well, in theory, anything should show up in /dev, but I don't think it's something that you can easily get at. Probably the easiest way to control it would be to load the appropriate drivers for NVIDIA, and they probably have a proprietary binary that will tell you all kinds of things about that device. The output on your screen that you had earlier, if you scroll up just a tiny bit where you were at, right there, that's telling you that the driver is Nuvo. Nuvo is an open source, basically reverse engineered driver for NVIDIA controllers. ATI has an equivalent as well that the Linux community has sort of put together, although their driver sets on Linux are actually from the open source side a lot of it better now because of ATI's sort of commitment to help there. But anyway, Nuvo is the open source reverse engineered driver. You'll get probably much better both performance and information by loading the closed binary. I'm not sure if what machine you have here, if this is a Linux box, what kind of distribution you have.
It's a Linux box. What do I have on here? I have Ubuntu or what?
You could. Yeah. Is it Ubuntu?
Mm-hmm. It's Ubuntu.
I believe there's some nice-ish way in Ubuntu, although I haven't run Ubuntu for over a decade, so I can't really tell you off the top of my head to just go ahead and download that automatically through Ubuntu's repositories. Alternatively, you could go out to NVIDIA.com and download the driver, probably as a deb package, which would work with Ubuntu and load it in that way, which would unfortunately probably, well, I don't know, maybe in the more modern ones they have some kind of automatic kernel module thing, but it used to compile a kernel module for the driver, which is essentially what the Nuvo stuff is. It's just built into the Linux kernel because for the longest time NVIDIA, well, even now NVIDIA doesn't provide basically any help for the open source community in that manner. They just give you their closed binaries and say, hey, if you want this to work like you should use these. If not, then you're more
okay. But
try to hack at it.
Let me just try to understand. I mean, like, for example, so MXNet is then supporting directly who is doing things like deciding how big the GPU's memory is and deciding how big the blobs of stuff that you put in the GPU are, all that kind of stuff? Who's doing that? How is that working?
So we have control over some of it, and MXNet is obviously the one that allocates the memory.
Okay.
So,
do we know how much memory we have to allocate? How does it know how much memory to allocate?
it tries. So it has some plan. So it says, okay, this is how much memory we try and allocate things, and so there's two different kinds. So MXNet has two different kinds of allocation modes. So one is that it can have, it just sees the plan for the network, and it can say, we need this amount of memory for that. But there's parts of the network, especially for NVIDIA's own primitives, that will run a little bit, and they'll test themselves out on that particular GPU, and they'll decide how much memory they want.
Okay. So how many of our layer primitives are GPU enabled through the NVIDIA essentially driver for their GPU?
All of them.
All of them. Okay. Interesting. Okay. And so if we simply run an evaluation network through, and we say, so is it the case that a random layer has a target device option?
Yep, every layer has a target device option.
Did you explicitly document that? I mean, if I say like element-wise layer, for example, or something trivial, is that going to say in its documentation here?
It's not documented because it's not particularly interesting, but it's supported.
Why do you say it isn't interesting? I mean, okay, let me ask a different question. Okay. What
so I'll give you the answer very quickly for why it's not interesting. So for layers so basically individual layers, if you don't have much computation that's happening on the GPU, then the overhead of shuttling data between GPU and CPU is basically
it's not worth it. Yeah,
it's not worth it. So
okay.
This, a rectified linear unit, it'll be vastly faster on CPU.
Well, just doing it once, right?
Just doing it once.
Okay, so what is the speed up that we expect? I mean, like if you run right now on your GPU, can we see if you run it on your GPU? Can we see some timings relative to CPU, just for my information?
Sure.
Okay, can you share and do that?
Yes, I can do that.
Also, what is the story with OpenCL on the Mac? Is that still alive, or what happened to it?
I mean, Apple has deprecated any support for OpenCL. They think it's a dead format, and they've.
So, what is their plan for GPU support?
So they've got something called Metal.
Yeah. Okay, but how does that? Okay, but bottom line for MXNet, since Apple has been a contributor to MXNet, one would think that it should run on their hardware.
I mean, they use it for research purposes. They don't care about shipping it to every machine. They have a very different, I mean, they have a very, very optimized network evaluator that they ship with Apple devices.
And are we able to use that?
Not yet. So
what would be involved in us using that?
The simplest approach is basically ONCs. So ONCs is a converter to Apple's formats. So once you're in the ONCs ecosystem, there's all kinds of nice adapters for the other formats.
Okay, so let's do this, and then
okay, so this is like for the nets, that's about 1,600 inputs per second.
Okay.
And if we do this GPU, and this is a very terrible GPU, a laptop GPU.
What's that? Preparing data for input port. What does that mean? Okay, so that's about 3 times, something like that.
Yeah. For a laptop GPU, that's kind of what you'll get. For a crappy laptop GPU like this one, that's 5 years old. But if you have a top of the line GPU, it's a very different ball game.
Okay, but first point is, like, how does a person, we don't have a system information way right now for people to even figure out if they have a GPU, right?
That's correct.
I mean, that's kind of upsetting at some level. I mean, if I run system information on this machine, so hopefully there we go. It's nice. Okay, so it's going to give me a bunch of information about the machine. It's going to give me devices information. That devices information, I don't even know where the devices information is coming from, but that's not telling me anything about GPUs. Would you expect it to?
So it's a tricky question because the way they would do it is either get CUDA link and then display it. That's one way of doing it.
But I was getting raw information from I mean, here I was getting some, like, for example, even running this LSPCI thing is giving me some idea that I have a GPU. What's the most robust way by making a system call on a Linux operating system to find out if you have a GPU? So somebody was suggesting here the this just catting. I mean, if we simply import /proc/CPU info. Actually, we can just read it as a string, right? Okay. And does this have anything about, well, let's find out if it has the word GPU in it.
Definitely will not.
Because it's about the CPU only.
Right. It's just telling you what feature set and what model and code and speed and caches, all the things about the CPUs.
Okay. Okay, so Warren, do you have an answer to this question? What's the best way to find out if you have a GPU?
My experience here would definitely not be super valid. I mean, most of my GPUs are just as an end user on a desktop machine. Like I said, loading up a driver, and I've never done anything with you know using a GPU as a computable device like Bitcoin mining or anything like that. So I'm not the person to answer this question, probably.
Fair enough. Okay, so right now for our users, we have no plausible way beyond telling them some complicated chain of things involving downloading drivers to even find out if they have a GPU. A fair statement? It's like open up your computer and figure out whether that chip is there.
I have a quick question.
Yeah.
The graphics subsystem, the OpenGL, there's a second one there on top of the one you expanded. Does that one? That's
an ATI. That seems to be another ATI. That's because I have two displays. No. What am I talking about? I have no idea why this machine, which is a headless machine, I believe, has two graphics subsystems in it.
That's yours, Mac.
Yeah.
Wait a minute. This is running on. How can it be running on?
Well, the devices from the front end, because it's Apple Thunderbolt display.
I see. Machine here. Well, that's again very, very confusing. So is this running? Okay, this is the kernel.
Right.
And that's running on Upsilon.
Mm-hmm.
But you're telling me that everything else here, okay, so the front end is obviously the local machine. Okay. And I don't know what the machine means. What does that mean, I wonder? Okay, that branches into a separate issue, which we should address with the core software engineering folk about what system information is doing with remote kernels, which looks kind of nutso to me here. Like, which machine is this talking about? Do we know?
No, but what I was going to suggest there, as far as the GPU stuff, is whatever calls they're making in the front end to get that information for OpenGL could likely be run on whatever. Assuming you're connecting to a remote kernel, here's what you're talking about, could potentially be ran.
But what are those calls?
I don't know the answer to that question.
I see. So you're pointing out that whatever this device thing is here, and the thing I'm a little bit confused by is how do I run system information? I see. If I run system information over here, Yeah, look. I can do this. If I just do this, if I run it just absolutely raw, where there's no front end, okay, then I will get information here that should contain a lot of stuff. But in particular, it will contain devices. So let's take a look. System information of devices running on the headless machine. Oh boy, really? That's weird. So if I say network here, wow. Okay. Why would it say missing not active? Is that because Linux won't give me this information?
I don't know the answer to that question.
Okay. Okay, well, so
So I do want to mention something very quickly, just slightly orthogonal to this thing, which is that a longer term solution that would be very nice for users is some sort of cloud support, so that you can, train it on some cloud machine that has all the setup done for you.
sure. Well, but
That's
the question is that really what people want? People want to be able to do it on their local machines, but it's obviously a big pain. Now, do we have workflows about GPUs? Do we already have workflows documenting things about GPUs?
We don't, but it's on our to-do list for 12.
Okay, so we have no such. So this whole, horror story that we've just been going through trying to get my GPU configured, there is supposed to be a workflow that says what to do with that. Is that the idea?
That we haven't even discussed that sort of thing because it's so potentially complicated.
There is a tutorial for CUDA link, and it does go through in deep details about the issue. So it's not completely not there. It's just a bit outdated, is what I'd say.
Okay, so another question is, on this page here, our compatibility page, do we have, GPU architectures, but we're talking there about, the heck are we talking about? So that seems to be your tutorial. Is that right?
Mm-hmm. But is
this up to date?
No, it is not. It's definitely not up to date.
How are we going to keep this up to date?
If I had 3 heads, that would be useful.
Okay. So this is what CUDA information, if it worked, would give.
It does work on Windows, but you don't have Windows.
Well, not here right now.
Yeah.
Okay. But so this is okay. What does the 1 mean? That's one of the GPUs?
Yes. Device count.
What do you mean it's a device count?
You can have multiple cards.
But then each card is named, and that's its name?
Yeah, it has name over there, yeah.
Sorry? No, I mean, but that's the name of the type of device. But if you were to decide to send a neural net job to a particular GPU, you would name the GPU. You would say send it to GPU number 3 or something. Is that right?
Yeah, for NetTrain, for example, we're supporting that in 12. That syntax.
So wait a minute, how does that work? So that in target device, are you saying that target device has a name for?
So the way we're doing it right now is that.
What on earth is this? Okay, target device GPU, N. Lovely. The number of GPUs available on your computer. And what is this now?
So this is what we build MXNet against. We ensure this compatibility of this set of GPUs.
And what is the capabilities 3.7? What does all that mean?
It's just basically like a generation of GPUs. So there's a whole bunch of GPUs that fall into one generation.
Okay. But these are
And these are like in years. So basically, like the bottom ones are the most recent ones. So Turing is the latest one.
Okay. They're getting more recent. I mean, look at that. Oh no, their history is kind of funky here. Okay. Okay, but so, all right. So look, the original topic here is, well, all right. The original topic was how to tell people which functions are GPU enabled, and what. By the way, the compiler, our compiler, does not. How far away is our compiler from supporting, compilation to anything that can be used on GPU?
That's definitely a question for the compiler group. But the discussions we had with them about this particular topic a few months ago was that they said they were close to having.
So once that's the case, you'll be able to take a Wolfram language function. You will then compile it. I mean, if I just say function compile of, let's say, I don't know what I say, typed X, integer 64 or something. What do I want to say? Oh, that's not what I want there. X. I wish we had some examples on those pages. X squared. Is that right? So that's going to give me, okay, so then I say, how do I get, how do I actually see the LLVM code here? Function compile export string of this. Okay, so the claim would be, so what will be the workflow for making this? So let's say I have this compiled function, and then I want to run this on a GPU. What will I actually do?
So I think there's a target, like a compilation target or something.
There is a compilation target, that's correct.
Yeah, I think that the way that it would work is that the compilation target would.
Well, that's all well and good. So I can get GPU code out. I mean, just like right now, I think I can get a target. Let's see, compilation target here. We don't seem to Sushma bug. We don't have. We don't seem to have the auto completion for this compilation target. So the compilation target here for compile. The heck is this? That's something yet different again.
That's the old compiler.
That's the old compiler, and that's generating explicit C code from the old compiler. But okay, let's imagine that I successfully generated code here, and I don't understand, and Sushma, this is something you should ask compiler folk, what the relationship is in compilation target and the new compiler stuff. But let's say I have GPU code here. What do I do with it? How do I actually run it on anything? So for example, let me show you the example of something fairly different, which is the recent microcontroller stuff, right? Because there, what has to happen is there's this thing, microcontroller embed code, which actually pushes the code to the microcontroller. Is that what, I just don't know. I don't know what it looks like. I don't know what the operating system interface to the GPU is supposed to look like. In other words, if you have a function that is a bunch of GPU code and you want to simply run it and call it with certain arguments, how does that work? What do we think the top level interface to that should be?
So I think CUDA has something exactly like this,
okay,
where you can give it CUDA code and it will create a function, a Mathematica function from it. So I think it's called CUDA function load.
Okay, Fahim, maybe you can speak to that.
Yeah, there is CUDA function load. If you open documentation for it, you should have examples.
Okay, so that is analogous to the embed code, the Arduino embed code. What the heck does this do? So this loads it into my GPU. Is that correct? And then, but
Yes.
does it have an entry point or something for?
So we have something called C compiler driver, and we have NVCC compiler, and that's how we do this. That's how we compile to CU, and then we run it.
Okay, I'm sorry. Say that again. I mean, I'm a little confused here. So I've got a piece of code here. That's a piece of raw. What is that? Is that C or something? What is
It's
this?
a CU code, .cu file.
Okay. Okay.
So CUDA is like a weird dialect of C.
Yeah.
Okay. So like an Arduino, except not an Arduino, so to speak. I mean, just another weird dialect of C. Okay, fine. Okay, so CUDA function load does what? It says, I'm going to set up a function called add to. That's its type signature. Is that right?
Yes.
What's the 256?
I'm not the developer for it. But
It's probably one of the launch settings or something.
setting.
There's a block
No,
dimension.
it's a block
exactly.
dimension.
Yeah.
Dimensions.
Which is one of the launch settings.
What is a launch setting?
So there's like all kinds of things like parameters for like the block sizes and various other things of how you want to run this on the GPU.
Okay. Okay, but anyway, so we've got this thing, and this defines. So then, I don't really understand what's actually put on the GPU. I mean, the code. Okay, a GPU is sitting there, and does it have a bunch of code loaded on it, and it has entry points where you call a particular function in the GPU? Is that how it works?
The way this would work is that CUDA Link and MXNet Link actually they ship something called the NVIDIA runtime compiler. So at runtime, you can just give it a piece of code and it will just compile it at runtime, and you can then start using it on the GPU.
I understand that, but why is it giving a name here? That suggests that on the GPU. I mean, it's like in on a CPU.
Yeah,
like
so
I mean, it used to be the case back in the day. When I first used a computer, it had one program, and you just started at a particular, program counter location, except it was called a sequence control register back where I came from. And you would go to that location and start running. And then the idea that you could have multiple programs, and you would, I mean, does it have more than one program, or are you always just loading one program into it and running it? And if you need more than, why do you need this name if there isn't more than one program?
So in the C program, you can see, so you can define in C multiple programs.
Oh,
I don't know how the delegation happens to the GPU, but how much goes in memory or not at the same time. But that global thing, that __ global, means that this is a CUDA kernel function, and that can be called by the GPU. I don't exactly know at what point it's in the memory or not of the GPU.
Okay, so then CUDA fun here is, so this is returning this object with some mysterious internal state that is some kind of pointer to the GPU function that you can then call here. Okay, I think I get it. So this will be the same thing as, let's see. Yeah, all right, I think I understand. Okay, so the roadmap going forward is the compiler will eventually generate GPU code, probably fairly soon generate GPU code, and there will be a similar function for loading that. Now, the GPU code that this compiler is generating, is this going to work? The LLVM-based GPU code, is that going to work on sort of all GPUs, or is it going to, again, be just this particular sort of stack of NVIDIA GPUs on Windows or something? Anybody know? Not the right people. Okay. All right, fine. Okay, so look, our original question was, which indeed someone, Ali on the live stream, asks the exact question that was the original source of this meeting, is how to signal which functions actually can use the GPU, are GPU enabled. And what you're basically telling me is, for example, the documentation page for NetTrain could have a little flag that says I'm GPU enabled. However, it's kind of not as simple a story as that, because it's a fairly specific type of GPU, et cetera, right?
That's true, and also it's yeah, exactly, like CUDA, or is it OpenCL? So it's complicated. So it would have to be something like CUDA enabled, or who knows what, CUDA GPU.
Well, is that even correct? Is it the case that any go ahead?
So only stuff with CUDA should work, and so not any GPU would be supported. I don't know about MXNet, but obviously with CUDA stuff.
So let me understand something else. When we get Onyx export, right? Is it going to look like you get a network and you have run training in our system, and then you literally say export of the network, Onyx, and it will generate just a file? Is that what Onyx is? Is just files, or is it something else?
Oh, just a file.
Okay, so fundamentally, I mean, right now, if I say, if I just said netmodel Linnet or something here, I would have I keep on running now on this weird Linux machine, so just to be exotic here, and also to see if it actually works. Okay, so you're saying right now, is there any export that I can do right now for this?
You can export to MXNet.
So if I say export string this thing to MXNet,
just export. Well, actually, maybe
no.
export.
I mean, this will just go splarf all over my screen, right?
Cool.
So that is, wow, that's really short. Why is it so short?
I mean,
how
it's
can
a pretty
that?
Small network. So there's two things. So one is that so MXNet file format, unlike ONX is one file, but MXNet is actually two files. So there's this file, which is the definition of the graph, and there's another file that you can export to that has the weights.
Okay, but by the way, is there anything else we want to ask Warren here while he's here about configuring of GPUs? I think the main message was it's a huge mess. So thanks, Warren.
Okay. Good luck.
Okay, so I don't understand. If there are two files, what am I actually getting here with the export string of MXNet? Sebastian, where's the other file?
The other file, so we had this issue where export didn't support exporting to two files explicitly.
Oh, for goodness sake. What did you do?
So the temporary solution was that
it makes a zip file.
It makes a temporary file. Or you can specify.
No. That's a really bad idea.
We had no other options. Like we discussed this with the import-export team. They mulled it over.
Why didn't you make a zip file? Why didn't you make a zip file?
Yeah, a zip file might have been better.
I think it is better. So let's see. If I look at the MXNet documentation here, what it's going to tell me? Come on, as a JSON file and a corresponding .params file, that's not very helpful. So are you telling me that this somehow, where does it even reference? Does it reference the temp file here?
No, they're completely separate.
Well, where is the temp file? Did it go missing because export string just dropped it?
It's in the same location as the JSON.
Great. The location is on my screen right now.
And you can also you can specify array path, and then you can specify a place for it. So both an option. So export string, yeah, I don't know what export string is supposed to do for that.
Well, let's look at the MXNet elements here. Okay, this is a bit of a screw up, if I might say so. Okay, so this has import elements. Why does it not list export elements? Right, because if you had export elements, you'd have a fighting chance. You could say MXNet export, and then give me the params file, or give me the whatever this other one was called.
So for the options, so the one way for being explicit is with options. So If you see the options tab, so for export, you can specify where you want to put the arrays.
No, this is not a good design, guys. Come on.
So the idea was that this would be a temporary design until export supports multiple files.
And when's that going to be? Because there's nothing that is driving that to happen, to my knowledge. And what exactly is it supposed to do under those circumstances? I think the only thing it can reasonably do, because you want a thing that you can pass around, the only thing it can reasonably do is make an archive.
So that's true. I mean, the archive solution is a reasonable solution.
I think that's what you should implement. I think what you have here is unusable in a first approximation.
So for the longer term thing, what they wanted was, I mean, there's different designs, and this had to be discussed as well. But yeah, either like returning a list of like 2 different paths or an association that tells you exactly where the 2 things are.
No, but that's not a good idea because look, in the case of export to a file, right? You could in principle have a directory, and it could export to a directory, and the directory could have multiple elements in it, right?
Sure.
But in the case of export string, that's not possible.
That's
I mean, I suppose the right way to do it. Okay, look, I'm taking this back a little bit. Probably the right thing to do is that export should export to a directory. An export string, in that case, should produce an association with 2 strings in it, or multiple strings in it. An export byte array, the same idea.
Exactly.
That's probably the correct solution.
And just some context for this as well. So the reason, so there's a symmetry that for certain formats, like for example, protobuf, like input formats, they have often multiple files. So we wanted to have this sort of,
I think the thing I just described is not a totally stupid solution.
Okay.
And let's see whether we can. I asked if we can find Shadi here. Okay. So, all right, but basically, your claim is that if I were to take this MXNet file, I mean, for example, the standalone MXNet executor would be able to ingest this pair of MXNet files. Is that true or not?
That's true. So you can create an MXNet executor with both those files.
And can we do that right now?
Sure. I mean, there's a Stack Exchange post about this as well.
But I mean, is there a function that we're providing that does it? And then what does it actually do? Does it emit ultimately a C executable or something, a binary, a pure executable compiled for some machine, or does it emit C code, or what does it actually do?
So there's different versions of the MXNet runtime. So there is a runtime version for MXNet that's pure C code. And you can use that, on whatever device to run your exported MXNet net.
Although that presumably won't work on a GPU because it's not GPU C, so to speak.
It'll only be just C.
Mm-hmm.
So that's the option that you've got for MXNet. And then for other formats, like ONCs, obviously, there's a whole bunch of runtimes that different hardware platforms provide. Like NVIDIA has a native runtime for that as well.
Okay, so what is our plan? I mean, is embed code the mechanism that we'll use to generate those runtimes? Is that the right thing to be using, or is it something else? Because this is a very similar problem. Okay, so let's go through the analogous situations. Okay, so with an API function, right? We have something like whatever it is, and we can say, embed code. Actually, I should have given a better example here. If I say, this is a terrible example of an API function. If I say x arrow integer, for example, and then hash x squared. Okay, so there's an API function. I apply it to this. I get some. Oh yeah, right. Right, thank you, API function. So what I have to do here is I have to say x arrow 78 or something. Okay, fine. And I can run that API function in the cloud and all those jolly things. But now I can say embed code of that API function, comma, well, let's say C#. Okay, so what that's doing is it's generating that C code there. And I suppose what we would want, no, it's not really correct. No, it's not really correct. What instead we want, I'm sorry, I'm wrong about this, okay? Instead, I think we want to use export, and we want to export it as a net model, export the net model as some format that might be called, MXNet runtime. Does that make more sense? And that will then generate a file that might be the, I don't know, MXNet C runtime, let's say. Now, obviously, that wouldn't have import. Does that make sense? And that's then generating a file that can be transported away and used in the, compiled to make make a pure runtime version of the MXNet system, so the MXNet network. Yes? No?
That's a possibility, yes.
Are there any other possibilities?
Well, so the thing is, if you want to run efficiently on a certain platform, so something like iOS, you don't want to run it, you don't have your own C runtime. You want to make use of the runtime that ships with, and the same thing with Windows devices or any other device. So Windows devices, for example, ship with highly efficient runtimes for particular formats.
Okay, so then you might want to say something like iOS runtime here. Right, and then we would generate something for that, I would assume. Or maybe it's just MXNet runtime and then, target device arrow, whatever. I'm not sure. Or target system arrow, whatever, along like the compiler. Makes sense? I mean,
that makes some sense, yeah.
But we need an actual design here to get something where, in the end, there's going to be a file, and you take that file and you do something with it on that device.
Sure, exactly.
And that file will typically not be particularly small. I mean, it'll be tens of megabytes typically. Is that true?
Yeah, it's the same size as what we stored in.
Right. But so, okay. I mean, is this something we could implement now to get out the MXNet C runtime version?
I think it's a possibility. So there's the messiness of this whole thing. So just the network itself, we can definitely do that. The messiness comes with things like encoders and decoders. So that's where,
yeah, that's where the Onyx thing is supposed to help.
Maybe, but even Onyx, like it's not, it's got simple image pre-processing, but it doesn't have.
I thought we gave them a bunch of stuff for doing this.
No, not yet.
Okay.
So Onyx is not a solution properly for that yet either.
So we need our own wrapper. Is that wrapper compilable with our compiler?
That seems highly unlikely, given that we depend on lots of dependencies. Like our audio encoders, they use all kinds of audio libraries. There's the image encoders use image libraries. It's a very messy thing. I'm not sure if the compiler has any chance.
Well, so you're saying it's not possible to make a standalone system there?
Not at the moment, no.
Will it be possible for any of our networks? Or are all of them, I mean, like a standard image-based network?
For images, it's much more possible. Like image libraries, there's probably a lot of standardization we can have for that. But for other things like audio or for some of our tokenizers, like they're quite complicated. There's no chance. But yes, for some networks, for sure, it'll work.
All right, so let's summarize this meeting, okay? First point, getting system information to know about GPUs seems seriously difficult. Fair statement? Or we don't think we know?
I think we don't know.
Okay, fine. So that should be taken, Sushma, that's for you, to the core software engineering folk, and ask that question.
Mm-hmm.
Okay. Second thing, the idea of flagging pages with whether they have GPU, CUDA support. In principle, if we had a good way to test whether something was GPU enabled, we could, at least in product, have some kind of indicator on this page about GPU support, or we could have a static indicator that says, if you happen to have this GPU, then it will work.
Yeah, we've talked about similar kind of indication, so I'll add this to my list.
Well, but the static one is one, seems readily doable. So what will we say? We would say something like GPU enabled, and then in little letters underneath, we would say CUDA or something. Is that what we would do? Or what? Guys?
I think that's fair.
Yeah.
All right. And what pages will we put this on? Basically all the neural net pages and very little else. And the various derived neural net pages like speech recognize.
Exactly.
All right. Well, Brady, I think that's for you then. Why don't you get that little thing designed?
Okay, 412, we're saying.
Well, I think we care about it for that. Do you think we care about, for example, something like speech recognize, is it going to have a target device option?
It does, but let's see options.
What is happening here? Oh, there we go. It does have one. Okay.
Yeah.
Okay. Fine.
So, going back to the system information question, the tools already exist. CUDA information does work given that drivers are properly installed. It will work. So on Windows, if your drivers are properly installed, you do CUDA Q, it will give you true. So all the code does exist. The only issue over there is you might not have proper drivers installed.
And how would you know that? You get a bunch of error messages or what?
Sometimes it crashes. When you do CUDA Q, it crashes if you don't have a proper driver.
Oh my God.
Yeah, it's a hard thing. I learned it yesterday when I was working on my machine, but it won't. It's very hard to.
Just tell me how much of a crash. Is it like a crash that crashes the operating system as well, or is it just
no, just the kernel.
Okay. Who knows?
The bigger thing we want to avoid is that you have to download a gigabyte just to learn the same thing that you could have learned from what we've already installed, right? Like that's the big duplication.
But that's the CUDA link does it the correct way. Any other way would be, that's a distribution problem, the gigabyte. It could easily be split up if the person knows which computer.
Right, but this assumes the thing we kept on looping around earlier, that there is no simpler, lighter weight way to tell from the operating system whether you have a GPU installed. That you have to download these drivers to know whether you have a GPU.
Yeah.
Which seems kind of weird to me.
There might well be simpler ways to do this, but I'm just pointing out that CUDA link requires a download of libraries that already exist in the install.
But they won't for long.
But not for long, according to the bug you reported.
What do you mean not for long? Not for long that they're duplicated, or not for long that I don't know?
Well, then we might not be shipping them with the product because they are too big.
Yeah, I think we shouldn't if they're that big.
Right, because it's 1.5 gigabytes at the moment just for MXNet. And the reason that is because they are trying to support multiple GPUs. And as long as
fine.
that is the case,
Well, that's crazy. We should not be spending 1.5 gigabytes for everybody's distribution, for the sake of supporting, of having a kind of a vat of random GPU supports.
Agreed. But for 12, I don't think we have any choice. I think the alternatives are too destructive. And
Well, no,
too
we just have it download on demand when you want to.
I mean,
GPU.
So
not for 12. That's too complicated for 12 to change what we're doing. I mean, unless we want to delay the release, but I don't think we can change our mind about how we implement,
but
GPU support.
But it's a packlet, so surely you can just download it with the current packlet system.
It's not as simple as that.
Why?
Because you have to, when you load the library, you've made a choice about whether you want CPU or GPU support. So if you want GPU support, then you've got to, and you want to download that separately, then you've got to restart Mathematica in order to achieve that. That's a whole different, it's achievable, but it's a very complicated dance.
I don't understand. Is it the case that the 1.5 gigabytes is already being downloaded in 11.3 or not?
It's part of the product.
In 11.3.
Yeah, I think it's smaller in 11.3, but it's part of the product.
Because that's, 1.5 gigabytes is a very large lump of downloaded stuff.
Definitely less than 11.3, but I think it's because we support fewer GPUs. But
have we talked to the release engineering folk about this? Because maybe there's a different solution that involves,
So this goes back to Alex's days. So we had a long debate about how to do this stuff. And it was decided by release engineering that the only sane way of doing this in the beginning would be to have a single MXNet that we ship.
But why can't you just remove the flags and just support one popular GPU card or something like that? That would reduce the cost immediately.
I can explain many reasons why that's not ideal. So do we want to go into that?
Well, I think we need to figure out how to save the 1.5 gigabytes.
Sure.
Which is ballooned, presumably, from something much smaller.
And it's only 1.5 in Windows. It's 1 gigabyte on. It's less than a gigabyte on Linux and Mac.
And on Mac, it's never going to work, right? Well, you might as well not download. What's that?
Well, we had a lot of customer pushback when we deprecated GPU support. So there's a lot of external GPUs you can get. So you can run the latest GPUs if you have an external GPU holder.
I have one.
Tally has one.
Hanging out of your laptop or something else?
It's like a box. Yeah, it's a box that you power and then you connect with USB-C. But to go back, yeah.
While I understand that it's necessary, but it seems unreasonable for people not interested in GPU to have to download 1.25 gigabytes.
No, sure, it makes sense to not do that, but the complexity.
Okay, listen. This is the wrong group. We need to. If we're going to have this discussion, we need release engineering folk, and I'm afraid this is a rock we just turned over, where we actually have to figure out what's crawling around underneath it. So, if you guys can set up, I don't need to be involved in it in the first instance, a meeting with the release engineering folk to try and come up with a solution. That would be good. And if necessary, it may end up being that there's, that you can choose whether you want to download the GPU-enabled version or not.
The big obstacle to having any kind of download on demand thing is that it's just very complicated. It'll
fine.
Take us...
Well, maybe it'll end up with two binaries, and one of them will be, with GPU and the other without.
Sure.
Or two distributions. Yeah. I don't know, but you got to talk to the release engineering folk, and they're going to freak out about this at this stage in the release process.
I think it's unrealistic to change the way we're going to release this next product. I don't think we can do that for the 12 timeframe.
Well, I don't think. Look, if it turns out we added a gigabyte to the distribution for the sake of exotic,
where did that come from? That really did not.
What was it in 11.3? What was the size of this packlet in 11.3?
It was probably like 400 megabytes smaller or something for Windows, and for other ones it was maybe 200 megabytes smaller.
All right, okay. Well, so we already burnt this gigabyte, is what you're saying. We already burnt that gigabyte.
Basically.
Horrifying. Totally horrifying. Totally horrifying. But fair enough. Still, you need to talk to the release engineering folk about whether there might be a solution here. Okay, and if we're lucky, there's a solution for 12.0. Otherwise, there's a solution for 12.01 or 12.1. Okay, so that was first item here. The flagging of GPU-enabled functions. We know that. You guys can provide a list of functions which should have that. It's basically functions that have the target device option. Is that correct? I mean, you're saying element-wise, in principle, it's GPU-enabled, but there's no point in mentioning that. Correct?
There's no harm in mentioning it.
Well, it's not going to be very useful to mention it if there's no way for somebody to access it because we don't document the target device option.
Sure. I mean, this is like one of those weird consequences of the fact that we don't have, we have all these layer functions, like element-wise layer and threading layer and all these. But our long-term vision is that we have much fewer of these because we just have net function.
How wonderful. How wonderful. That's what we hoped we would do at the very beginning. But yes, go ahead. I'm sorry. I'm instead of having a zoo of special function layers and so on. Okay,
sure.
Great.
I mean, look, you can complain that we didn't have this at the beginning, but we did have a functioning neural network framework.
I'm well aware. I'm well aware. That's why I'm not complaining that hard. Yes, I'm not complaining that hard because we knew that perfectly well when we went into this. We started off thinking, exploring the possibility of a very elegant functional design, and then decided that it simply couldn't be done yet, and that was the right decision.
It was. If we wanted neural networks for the last
we could have just waited 5 years, but the alternative was to have the kind of thing we have right now, which is just fine.
Exactly.
And which will eventually become the low-level layer. The low layer is used in a punned way here, but I mean the low-level, low-level ecosystem or something, infrastructure for the stuff we actually build. But okay,
sure.
So are we going to document target device in all of these random layers?
I mean, personally, I think that's a waste. I think we should not spend time on documentation of functions that are kind of going to be irrelevant in 6 months.
I love your modernizing. Yes, I basically, I'm okay with that decision. Okay, so we'll only document functions that are crunchy, like image restyle, speech recognize, those kinds of things.
Exactly. NetTrain and NetGraph, NetChain.
Right, but those are things that already have the target device option, right? Exactly. So we simply put the flag, we put the little GPU-enabled flag on everything that has a target device option.
Correct.
Okay. What else do we need to do here? We've also got this business about. We've also got this export formats thing, which is probably not a 12.0 story, but is shortly after 12.0. We've also got the question of multi-file export, which I think we got a reasonable design idea for, which might as well be implemented, right? Of just generating an association for export string and generating a directory for export. The only thing that I can see that's wrong, what's that? Is Shadi here?
Yes. Is this something I should know about as well?
Yes, absolutely.
Okay.
This is work for your team.
Okay.
The issue is MXNet export really deals with generating 2 files.
Right.
And some total hackalola solution was made for this that involves writing 1 file into a temp directory.
Yep.
Horrifying. Do we have many? Yeah. Do we have other formats that have export to multiple files?
No.
It's just never come up in any other case.
For import of protobufs, we did discuss the similar thing. So we were going to look into, in general, association support both in import and export, where you give keys to individual file types and then the path to that file. I think there needs to be some framework level update that we can support these kind of
I agree.
taxes, and then whenever it comes up in the future.
So what I'm suggesting then, Shadi, is that we basically have, normally on export, it would write a directory.
Okay.
We might have an option to write a zip file instead.
I see.
Okay. Now the only issue with that is if you if you export and then you want to delete what you exported, and you say delete file on the directory, does it work?
But let's check. So,
But I'm curious. Like you say that the normal things to export to directory. I haven't seen that before. Is that something that exists now?
No. I'm not saying it's a normal thing. I'm suggesting that's what we plan to do in the future.
I see.
I think that should be one of the modes. Alternatively, I don't know. You're suggesting that maybe the good default, right, Stephen?
Yes, and then the alternative would be a zip file.
How about just at the working directory, just the 2 files? That should as well be a mode. Maybe
possible, although that violates another principle of export, which is that the name of the exported, that there is a known. Well, okay, fair enough. That's a reasonable mode. Also, I
mean, what does it return? Export always returns something that is
the name of a file.
usable.
It returns the name of a file, so it would have to return an association, which would also be what it could be used for input.
Exactly.
The association would be
exactly
the file type arrow, the name of the file.
Right.
Yeah, that's an important principle to maintain that kind of round trip ability.
Right. Okay, then the other case is export string and export byte array, which I claim should return an association. Right, like it could say param arrow and then the string for the parameter file, JSON arrow, and then the string for the JSON file.
Mm-hmm.
Same for byte arrays, presumably.
Exactly. And in terms of import string, import byte array, it will work just exactly the same way, because otherwise it can't eat an association. I mean, that would be its only way of consuming an association would be the mechanism like this.
Right.
Okay. Well, all right. I think we have a plan there. Anything else we need to cover in this meeting?
Sounds good.
Okay. And the other thing that came out of this is the need for workflow documentation for the absolute horror of setting up GPUs.
It's not that. I mean, it's not really not that bad. Like, I mean, we do offer a better experience with using GPUs than basically any other framework. So I don't know if absolute horror is quite the right phraseology to use.
But what he's meaning is like the device drivers and things, and you have like 10 different brands of Linux and whatnot. It is a horror.
I mean, at least we do say that you're using XYZ device driver, and you should be using ABC device driver. That is better than everyone else does.
Right,
well,
that's good.
The messages we provide, yes.
Okay, so actually there's another piece, Sushma, this is for you. The compatibility page needs to be spruced up to describe whatever it is we think just like you have that list of in target device, you have that list. That's the list from target device should make its way onto the compatibility page.
Yes.
Make sense?
Yep.
That thing.
Yeah.
Okay. All right. Anything else here? Make Okay.
Nope.
Thanks all. Thanks to folks on the live stream. Yeah, it was a bit of a horrifying discussion here. Yes. Ben on our live stream is complaining that 1.5 gigabytes is huge. Yes, you are right. And we need to not be downloading that for everybody, for the sake of the microscopic fraction of people on a Mac, they're downloading it for their laptop, and most people don't have a separate GPU that's hanging off there. All right, good stuff. Thank you all. Yeah, great. Okay, see you all later. Bye-bye.